The best way to work number 30 is to use the calculator. We do have the opportunity to work it by hand if you want to make the rest of this table. So to find the mean, remember the mean of a discrete random variable x is the sum of x times the probability of that x. So we can make another column, x times the probability of x, to simplify. 0 times 3/17 is 0, 1 times 5/17 is 5/17, 2 times 6/17, 12/17, then 6/17, and 4/17. So that comes from just multiplying these two guys together, and then we'd have to add them together. So definitely would need a calculator for that. 0 plus 5 and 12 and 6 and 4, which I can do to be lazy because we have one common denominator of 17. But if you wanted to, you could just add the full fractions. 5/17 plus 12/17 plus 6/17 and 4/17, or 1.588, or 27/17. So that's the mean. The mean, 1.588. To find the standard deviation, we have a new formula for that, also on the formula sheet. Sigma x, the standard deviation of the discrete random variable x, is the sum of x squared times the probability of x minus the mean squared. And we already have the mean, so we can put that in where we need it to be. But we have to make a new column for this piece, the x squared px. So on the by hand method, make another x squared px column. 0 squared times 3/17 is still 0. 1 squared times 5/17 is still 5/17, and etc. 2 squared is 4. 4 times 6, 24/17. 9 times 2, 18/17. 16 times 1, 16/17. Then we'll have to add up those guys. Again, common denominators, fortunately for us. 5, 24, 18, and 16 make for 63/17, or approximately 3.70588. So then, just to finish the formula out, we need to take the square root of this number we just found, the sum of x squared times px, 3.70588, minus the mean that we found previously, 1.588, squared by the formula. The formula said squared, so square it. I like to do it all at one time in the calculator. Take the square root of this answer I had before. You can either go up and grab it or press second answer, minus the mean we had, 1.588. I wish I wrote down more decimal places, but I think this will work. Is 1.088. So the standard deviation, 1.088. In the calculator, the fast way is to enter the values into the list. So list 1 was 0 through 4. And then we need to delete these remaining values. And the next column are the probabilities of those values. 3 out of 17 for the first one, 5/17 for the second, 6/17, 2/17, and 1/17. So now we have the x's and the probability of x. Quit that and run one variable statistics on the two lists. We have a mean, 1.588, matches our mean, and the standard deviation, 1.087 or 88 if we ran to 3 decimal places.